Hello my dear students, welcome to maths class. Today we are going to start our new lesson, that is circles, which is the second lesson of class 10 mathematics. Do you know what is a circle? In the figure you can see a circle, right? And what is a circle? A circle is actually the locus of all points that are equidistant from a fixed point. See, here you can see a point is moving, right? And the movement of that point forms a circle, right? So, that is actually a circle. The locus of all points, locus means path of all points that are equidistant from a fixed point. On the center you can see a point here, right? And this point and this points, all the points around this circle keeping the same distance. Okay, so that is what we call a circle. The locus of all points that are equidistant from a fixed point is called a circle. And do you know different measurements of circles? Yes. Which are the measurements? Yes, one is radius. What do you mean by radius? See, here you can see a line segment. That line segment is the radius of the circle, and the distance between the center of the circle to any point on the circle is called the radius of the circle. Okay, the distance between, this is the center of the circle. Here you can see a point, that point is the center of the circle, and here you can see another point. So the distance between that two points, that is the center of the circle to any point on the circle, is called the radius of the circle. And we always draw a circle using the radius, using the measurement of radius, right? Now we are going to check what is the diameter of a circle. What is diameter? Yes, diameter is actually double of radius. That is, diameter is 2 times of the radius, or radius is half of the diameter. Okay, so diameter means, yes, diameter means the distance between 2 points on a circle, distance between 2 points on a circle, and that line, or the line that passing through the center of the circle and touching 2 points on the circle is called the diameter, or the double of the radius is also called the diameter. Okay, then what is a chord of a circle? In the last year, you know another some parts of circles, right? That are, yes, chord of a circle, segment, area of a circle, perimeter of a circle, etc. Right? And what is chord? See, diameter is actually the largest chord of a circle. Diameter is the largest chord of a circle. Then what is a chord? Chord means a line segment connecting any 2 points on a circle is called a chord. Okay, so here you can see this one. See, this FG is a chord of the circle. Okay, FG is a chord of the circle, and we can see that this diameter is also a chord of the circle. That is also the line connecting 2 points on a circle, but it is passing through the center of the circle. So diameter is the largest chord of the circle. Okay, diameter is the largest chord of the circle. FG is a chord. Chord means what? Chord is a line segment joining 2 points on a circle. Okay, so what is a chord? Line segment joins 2 points on a circle is called a chord. Okay, and one more thing, diameter is the largest chord of a circle. Yes, this is what we called a sector. Then what is a sector? A sector means it is the area or part of the circle that is enclosed by 2 radii. See, here you can see 2 radius. right? Yes, one is a see this AC and AB are two radii of the circle. Okay, then a segment is the part of a circle that is enclosed by two radii and an arc. What is an arc? This part is called an arc. Okay, this BC is called an arc. So the area enclosed within two radii and an arc is called the sector of a circle. Then what? How do we find area of a circle? We have an equation. What is that equation? Area of a circle is, area means what? See, area is actually the, yes, see here, see this red portion is actually called the area of the circle. Okay, that means that red color is called the area of the circle. Okay, then how do we find area of a circle? Area of a circle is got by this formula pi r square. Pi r square is the formula to find out area of a circle. Okay, then what is the perimeter of a circle? Perimeter means what? This is what we call the movement of the point. Yes, the movement of the point, that is what we call the perimeter of a circle. That is, if we use a thread to measure the circle, the length of that thread is actually the perimeter of the circle, and we have an equation to find the perimeter of a circle, that is 2 pi r, where r is the radius of the circle, and we already know a new constant. What is that? That is pi. And what is the value of pi? Value of pi is 3.14. Okay, now we are going to start, yes, 10th standard topic. Okay, these are some basics of circles, and our actual topic is not like this. Let us start our topic. Okay, in this figure you can see the diameter of the circle. The name of the diameter is BC and the center of the circle is A. And if I join the ends of the diameter, B and C are the ends of the diameter. If I join the ends of the diameter to a point on the circle, okay, suppose this is a point on the circle, and if I join the ends of the diameter B and C to this point, I will get an angle. And is there any speciality for that angle? Let us check. See, I join the ends of the diameter to a point on the circle, and the name of that point is, yes, D. Okay, that is the end of the diameter joined to a point on the circle D. Then I got an angle there. Okay, and what is that angle? Let us measure that angle. Okay, what is the measurement of that angle? See, that angle is equal to 90 degree. And if I joined to another point, if I got another angle, right? And what about this angle? Let us measure. Yes, that angle is also equal to 90 degree. Then if I join the ends of the diameter to another point, is the angle is 90 degree itself? Let us check. Okay, so this is another point, and I am going to join the ends of the diameter to this point. I got an angle. Then I am going to measure that angle. Measurement of that angle is equal to, yes, what is that angle? Yes, that angle is also equal to 90 degree. So that is a speciality of circle, that is, what is that? If we join the ends of the diameter to a point on the circle, we get a right angle. Okay, if we join the ends of the diameter to a point on the circle, we get a right angle. In another words, we can say that angle in a semicircle is right. We know this BC divide the circle into two equal parts. That means the diameter divides the circle into two equal parts, and each part are called semicircles. Okay, and this angle 90 degree, is enclosed inside the semicircle, and that angle is 90 degree. So we can say that angle in a semicircle is right angle. Okay, if we join the ends of the diameter to a point on the circle, we get right angle, or angle in a semicircle is right. In your textbook, here you can see a picture. See, one circle, one dotted circle can be seen here, right? That circles are formed by joining the ends of the diameter to different points on a dotted circle is formed by joining the ends of the diameter to a point on the circle. Okay, then what is our result? Our result is, if we join the ends of the diameter to ends of the diameter of a circle to a point on the circle, we get a right angle, or we can say that angle in a semicircle is right. See here, this BD and CD are perpendicular lines, right? This BD and CD are perpendicular lines. So the perpendicular lines drawn from the ends of a fixed line meet on the circle with that line as diameter. Okay, see, this BD and CD are the lines, mutually perpendicular lines drawn from the end of the line BC. Okay, that BC is the diameter of the circle, and that two lines, that two mutually perpendicular lines will meet on the circle. That means the two mutually perpendicular lines meet on the circle at the point D. Okay, in other words, we can say that if a pair of lines drawn from the ends of a diameter of a circle are perpendicular to each other, then they meet on the circle. See, BC is the diameter of the circle, and BD and CD are two mutually perpendicular lines, and if we draw a pair of lines drawn from the ends of the diameter of a circle are perpendicular to each other. So this BD and CD are perpendicular to each other. Okay, that is, if a pair of lines drawn from the ends of a diameter of a circle are perpendicular to each other, then they meet on the circle. Similarly, all pairs of mutually perpendicular lines drawn from the ends of a fixed line meet on the circle with that line as diameter. Okay, children. So what we have? Yes, we have a new result, that is, if we join the ends of the diameter to a point on the circle, we get a right angle. Okay. Yes, in this figure you can see another circle. Okay, and the center of the circle is G and the diameter of the circle is IJ. And if I join the ends of the diameter to a point inside the circle, okay, suppose this is a point inside the circle. Okay, what is the name? Name of the point is K. And if I join the ends of the diameter to a point inside the circle, what type of an angle do we get? Let us check. See, this is the ends of the diameter, and I am going to join the ends of the diameter to a point inside the circle. Then I got an angle here. See, let us measure the angle. What is the measurement of this angle? Yes, that angle is 105.36 degree. Okay, it doesn't matter. Now I am going to join the ends of the diameter to another point, and the name of the point is L. Okay, so let us join the ends of the diameter to that point. Okay, then also I got another angle, and the name of the angle is SILJ, and let us measure the angle. Okay, let us measure. What is the measurement of this angle? See, 122.22. See, all these angles are greater than 90 degree. So this is another property of circles, that is, if we join the ends of the diameter to a point inside the circle, we get obtuse angle. Obtuse means what? Angles greater than 90 degree are called obtuse angle. So if we join the ends of the diameter to a point inside the circle, we get obtuse angle. Okay, obtuse angle, that means the angles greater than 90 degree. If we join the ends of the diameter to a point on the circle, we get 90 degree, and if we join the ends of the diameter to a point inside the circle, we get angles greater than 90 degree. Okay, then there will be one more condition. What will be that? Let us check. Yes, if I join the ends of the diameter to a point outside the circle, see here you can see a point outside the circle, the name of the point is Q. Okay, here the center of the circle is M, and the diameter of the circle is OP. Diameter of the circle is OP, center is M, and Q is a point outside the circle. Okay, I am going to mark one more point here, many points here. Okay, let us join all these points, okay, with the diameter. Yes, so is formed. Then next this angle, next this angle. Okay, then if we measure all these angle, is there any speciality? Yes, let us measure all the angles. The first angle is 64.505, and the second angle is 63.57, and the third angle is what is that? That is equal to 46.95, and the next angle is what is that? 55.33. See, if we join the ends of the diameter to a point outside the circle, we get angles less than 90 degree. Angles that are less than 90 degree are called acute angles. Okay, so if we join the ends of the diameter to a point on the circle, we get 90 degree. Inside the circle, we get obtuse angle, that is greater than 90 degree, and if it is outside, we get an angle that is less than 90 degree, that are called acute angles. Okay, this is the first point that we are going to study in this chapter. Okay, so this is the first result of the chapter, that is, or the first point of the chapter, that is, if we joined the ends of the diameter to a point on the circle, we get 90 degree, and if we join the ends of the diameter to a point inside the circle, we get an angle greater than 90 degree, and if we join the ends of the diameter to a point outside the circle, we get an angle less than 90 degree. Okay, so let us do the first problem in the first exercise. See, this is our first question. Suppose we draw a circle with the bottom side of the triangle in the picture as diameter. Find out where the top corner of each triangle is inside the circle, on the circle or outside the circle. See, this blue color line is the diameter of the circle. Okay, suppose this blue color line is the diameter of the circle. Then here we can see three angles. One is 110 degree, second is 90 degree and the third one is 70 degree. We need to write where is the position of that three angles. Okay, this is 110 degree. 110 degree means the point or the top corner of the triangle is inside the circle. Okay, the top corner of the triangle. See, these two green lines and this blue line form a triangle, and the top angle is 110 degree. That point, that top corner is inside the circle. Okay, and for the second purple color triangle, the top corner is on the circle, and finally the orange color triangle and its top corner is outside the circle. Okay children, we will continue the rest of the problem in the next class. Thank you for being with me. Thank you.